Okay, welcome back. So we are already pros at using the Pythagorean theorem, right? We did that last time. A squared plus b squared equals c squared when you're trying to find the missing length of a side on a triangle, on a right triangle. Today we're going to apply that. We're going to kind of look and try to find the distance of lines that aren't really straight. Maybe it's the distance between 2 points on a graph. Maybe later it's going to be kind of the distance between 2 points on a map. I don't know, but we'll see, and I'll show you how to do this. So let's look at this first problem here. Now, one thing that I want you to know for sure is since this line is at an angle, we can't just count boxes. We can't just say that this is 1, 2, 3, 4, 5, 6, 7, 8, 9. We can't just say that that's 9 units long. It doesn't work like that. Now, maybe that's going to be a good estimate, but good estimate is not good enough for us. So let's see if we can actually figure out what it is. So first thing we're going to have to do is imagine this as a right triangle. And notice how I'm at least attempting to draw my lines, my right triangle, exactly on the lines of this graph. So I'm not taking any shortcuts. I'm not going across a graph like that. I'm staying right on those lines. Now let's see what those are. This side is 1. How long is this? 3, 4, 5, 6, 7, 8, 9. This side is 9. So what I have is a right triangle where one side is 1 and the other side is 9. And if I want to find this missing side up here, we know how to do that using the Pythagorean theorem. A squared plus b squared equals c squared. So this is definitely an addition problem. So all we're going to have to do is 1 squared plus 9 squared equals, and square root it. And when we do that in our calculators, we're just going to get 9.06. So the distance of that line is going to be 9.06. So all we have to do is imagine a right triangle there, count the length of the sides, count the units, and then use the Pythagorean theorem. Let's do another one. Once again, this is at an angle, so we can't just count the squares, but instead we're going to have to imagine a triangle, a right triangle going from one point to the other. And notice again that I stayed right on those lines, or at least attempted to stay right on the lines. No shortcuts. Okay, so let's see. How far is this on the bottom? 1, 2, 3, 4, 5, 6. It's going to be 6 on the bottom. And how far up the side? 1, 2, 3, 4, 5, 6, 7. So I'm going up the side 7. So I've got a right triangle. Once again, one side is 6, one side is 7. They're touching the right angle. This is an addition problem. 7 squared plus 6 squared equals square rooted. And let's see what that's going to be. It's going to be 9.22. So the distance of that line is actually 9.22. So all we have to do is see our 2 points on there and imagine a right triangle going into it, and then count the sides of the triangle and use the Pythagorean theorem. No sweat, pretty easy. But now what happens if we don't have a graph? What if we just have 2 points like this? 5, -3, and 2, 4, and I want to know the distance between those 2 points. Well, no worries here. All we're going to have to do is graph them. Let's graph this. 5, -3, so over 5 and down 3, and then 2, 4, over 2 and up 4. Let's draw this line right here. I want to know how long that line is. So here's what I'm going to do. I'm going to imagine or draw a right triangle here. Again, staying right on those lines. Now I can see I can count those squares on the bottom. The bottom is 3, and moving up the side, that's 7. So here's what we're going to do. Make that 7. There's my plus. This is definitely an addition problem. So we've got 7 squared plus 3 squared equals square rooted. And let's see what that's going to be. 7.62. So the length of that line is 7.62. Let's look at the last one. All right, so you can see that this, it may sound a little bit more confusing, but really it's just at its heart the Pythagorean theorem. That's all it is. So 2, 5. So I'm going over 2 on my x-axis and up 5 on my y. So there we go. And then -4, -2. So -4 on the x, -2 on the y. And let's connect this. All right, now I'm going to draw my triangle. Again, staying right on those lines. And let's see, on the bottom it's 1, 2, 3, 4, 5, 6. The bottom's going to be 6. And how about the side? 1, 2, 3, 4, 5, 6, 7. 7 on the side. So we've got a right triangle here. If I want to find that missing side, it's going to be just an addition for the Pythagorean theorem. 7 squared plus 6 squared equals square rooted. Let's see what that one gives us. That's going to give us 9.22. Okay, so one other question, just real quick. What if you saw a triangle different than I did? I drew my triangle in red, but what if you saw the blue triangle right here? What if that was the triangle you saw? You know what? The cool thing is it's going to give us the exact same answer, so it doesn't matter. Just draw your lines right on that grid. So you see that this distance formula here, all it is the Pythagorean theorem. Just draw your right triangle, count your sides, and then use the Pythagorean theorem. Now, in the next video, I'll show you how we can actually do this without graphing it first, and so that's going to be kind of cool. But this is step 1 to really understanding what this is doing. All right? I know you've got this. Good luck.